Oh, I see. Okay, cool. I'll just keep you on mute.
Oh.
Okay, 2 minutes. All right.
Seems to be a few people's audio struggling to connect.
This is the delicious one.
Good evening.
Hello, hi.
Hi, Martin.
Hello, Richard. How are you?
Yeah, I'm really good, thank you. Really good.
Good. Excuse me if there's some loud bangs. Someone appears to be doing fireworks just outside my office. So,
Well, you know, they obviously heard about the webinar.
yeah, exactly. That's it. Yeah.
Your grand entrance.
Yeah. As long as I don't get put on the bonfire afterwards, that's good.
Oh.
Yeah. So, how are things?
Everything's good at the moment. Yeah, I've been busy today. I've had I've done 3 talks today.
Oh wow!
I know, and it's I did my rehearsal for reInvent, which is our big AWS conference in December. I did that. It was meant to be a technical check, but they wanted me to present, so I did, and so I wasn't expecting that one. And then last night I got a call for the user group in Italy, the Italian.NET user group, who had someone from AWS drop out at the last moment and asked if I could do a talk. So I did. So yeah, third talk today.
It's not too bad.
I'm feeling super productive.
Yeah, I know you didn't get to go to Australia recently.
Yeah, exactly. That's the most, well, my it was what there's 2 conferences which were both around the same sort of time. One was the NDC Sydney, and one was the Caribbean Developers Conference, and both of those were like bucket list conferences, which was like, oh, that'd be really fun to go to the Caribbean to do a conference. I mean, that couldn't get much better. But yeah, both of those obviously got cancelled. And I didn't even get my NDC Sydney, a colleague of mine, took over in the end because it was easier with the time difference. And then the Caribbean one, I don't think that actually took place online. To be honest, most people are just disappointed that they can't go to that one.
Yeah.
No one wants it online.
Martin, I'd just like to say I'm James from Langley James, and I just wanted to say thank you very much for taking the time to do this evening. It's really, really much appreciated.
Oh, pleasure. Thank you very much, James.
Thank you. I'll leave it with you, between you and Richard and everybody else now. I'm going to watch it with eagerness. Thank you very much.
All right, James. Thanks.
Whilst we've got a crowd, James said that he'd let me go recruit from the Caribbean for a few weeks.
Did he? I think it's a good choice. Yeah. like a work. A lot of countries are getting visas now where you can go there just to work.
Yeah.
Like,
Oh, see that.
Yeah, the Bahamas are really encouraging that at the moment, aren't they? But I think you've got to go into 3-year quarantine when you come back from there.
I do the Bahamas, Caribbean, Canada, Australia. Yeah, and I will take my family as well. I mean, I think that's only fair. So
Not for the first few weeks. You got to scope it out, right?
Not at the same time.
yeah, they can follow a week behind. Yeah, no, I'm obviously joking, but that was, yeah, it would be quite a cool thing to do a on the road, sort of stay away for a while. Not, I mean, with the family, take them all on like a road trip. I used to do a lot of road trips around the UK when I was in a different company, but now it's just like event to event. It's not really a road trip, but I love the idea of doing like an international road trip. Oh, travel. We don't do any travel anymore. It's horrible, isn't it?
Well, I live in North Wales. Like, I literally can't go anywhere.
Oh, really? Is it it's illegal to leave, is it?
Even the house. Yeah. No.
Oh, really?
No.
So we just tied him down, really.
I mean, I just went to Halford, so that's like a luxury for you, right?
Yeah. Well, it's not. Halfords isn't open in Wales. It's not a necessary store.
No, but
Basically.
Yeah.
Hold on. Oh, they'll start filling in now.
do you have any slides, Richard, or do you want me to share them? Share my
No,
screen?
so if you do a screen share, and then it'll pop up on everyone's screen.
Yeah. Okay. You'll
So this
see
will be
my
what,
face.
talk number 4 today?
Sorry?
Did you say this will be talk number 4 before?
No, it's number 3. Yeah, it's right. So
Is that every day you do 3 talks?
I wished. No, it's not. Sadly, it's way less than that, actually. And more recently, it's very rare. It's just for some reason, because of the way things worked out. I've just done a lot today, and but what's cool about working remotely and with all this stuff is that I've been, to Italy, and to, like, not really, but obviously virtually to Italy. But then I've been to Seattle this afternoon, and then North Wales, speaking to Richard.
I can't hear anything on this one.
Okay, so we sent out an awful lot of invites for this one. I think people are going to filter in as we go on. But do you want to make a start now, or do you want to wait a few more minutes?
Yeah, absolutely. I can start. Thank you very much, everyone, for joining. My name is Martin Beeby. I am a principal developer advocate at AWS. If you are on Twitter, my handle is @thebeebs. And if you're on LinkedIn, my name is Martin Beeby. Please do connect, and if you've got any questions, or if you want to speak to me about perhaps getting some AWS credit, then please do email me, or and I'll give you my email at the end of this as well. Email me or connect on LinkedIn or connect on Twitter, and I will be able to give you a $50 voucher for AWS if you are wanting to get started. And even if you already have an account, you can still apply that voucher to your existing AWS account. And today I'm going to be talking about developing with .NET on AWS. I'm a software developer, and I have been a software developer since I was 16 years old. These actually slides are wrong in terms of my age, but I'm not going to update them, to be honest with you. I've been a developer for 20 years. So developer since I was 16, developer for 20 years. I won't do the maths. I'll do the maths for you, in fact. That'll make me 23 years old. Yeah. So, and I work at Amazon Web Services now and have done for about 2 years. Prior to that, I worked at Oracle. And then prior to that, I worked for 8 years at Microsoft. Most of my time has been as a web developer, but I've used lots of different technologies. I generally work in .NET and C#, but definitely done a bit of Node and a little bit of all sorts of things. So I've done lots of different languages over the years, but there's a special place for .NET in my heart. And AWS employ me as a principal .NET advocate. And the idea is that I explain how .NET works on AWS. Now, this slide is an important slide for me. And if there is anyone out there with a camera phone or the ability to snap their screen, please do take a picture of this, because this is my inception slide. And before lockdown and virtual conferences, you will note in the very corner there at the top, you'll see like me standing on a stage in front of a slide. So the idea used to be that it was a picture of me standing in front of my slides, and then I would replace the picture every night. And I've done this for nearly a year and a half, and it actually goes 50 levels deep at the moment. So I'm on, I think, level number 50. So I've stood in front of a slide, had the picture taken, put that picture in my next slide, and then had the picture taken again and again and again and again. So you can see that one above me, I'm wearing the same hoodie as I was, because I was doing that one this afternoon. That was when I was doing a talk in Italy. And then the one above that was on Monday night when I was speaking at Nottingham.net user group. And then I've forgotten where the other ones are now. But the last one on stage, that was in Romania, which was my last actual physical talk way back in February. So if you do take a picture of that, please do send it to me on one of my contacts, or tweet it out on Twitter. Include the Beebs in it, and maybe the hashtag Inception, and maybe I'll get to level number 50. If you want to see all the pictures that I've done since the beginning of the Inception slide, go to the Beebs.net, which is my website, /Inception slide, and you can see most of them. I do actually need to update it now. When I started at AWS, I knew nothing about AWS. So I was a .NET developer. I predominantly used Azure. For .NET specifically, I'd use Azure. And I didn't really have much of a handle as to what I could do on AWS, what kind of services were available for me as a .NET developer. But I got contacted because someone, my then boss, Ian Massingham, saw me speak at an event, and he knew that I did .NET, and he needed someone as a .NET advocate. And so he contacted me and said, well, you're good at .NET. We don't mind so much that you don't know anything about AWS. Come and learn. We'll teach you everything we know about AWS, and then you can teach .NET developers about AWS. So that's kind of my job. I go around the world speaking about AWS and explaining it specifically to .NET developers, although I work on all sorts of different things with different technologies, but predominantly with .NET developers explaining AWS. And when I first came to AWS, I was surprised to realize the heritage that .NET has and Microsoft workloads have at AWS. AWS was the first cloud provider to support Windows servers in the cloud, in a hyperscale cloud. And it was way back in 2008 that we had our first Windows Server 2000 instance. So if you have if you create a virtual machine in AWS, we call those instances, or EC2 instances, Elastic Compute Cloud. We call that an EC2 instance, which is a virtual machine. And we started supporting Windows instances way back in 2008. And since then, we've done, every time the servers have upgraded and there's been new versions of Windows which have came out, we've obviously supported all of those new versions. In AWS, you have these things called Amazon Machine Images, or AMIs, which are like the operating system and an image for that particular EC2 instance. And obviously, every time there's a new version of Windows, we have a new AMI for that, which is supported. We also have a number of AMIs for things like SQL Server. So since 2008, customers have been able to build Windows infrastructure. Now, obviously, with .NET, it used to be a Windows-only thing. So back in 2008, if you were a Windows customer, maybe if you wanted to build a large-scale website, or you wanted to have an application application which needed to scale. There wasn't really any other option than perhaps either to host it in your own data center, maybe use some colo, like, you know, a traditional hoster, or you could bet on AWS, who were kind of doing some new and innovative things in 2008 with the cloud. And a number of customers have done that and started with us in 2008. And around that time, very early doors before other cloud competitors even existed. So customers like, for example, Just Eat in the UK, they're a large .NET customer, and they started with us very early on when they first started. They moved to AWS, and they've been with us ever since. Customers like Skyscanner are also another big .NET AWS customer. And over this evolution, we've added support for new operating systems, and we've innovated and provided capabilities for Windows machines and Windows workloads. And now we're at a stage where we have the market share for Windows Server. So I think something like IDC say that we have 70% market share in terms of Windows workloads. And you know, we've got many different types of customers, not just building big websites or big applications, but also, you know, regular and small, medium and small businesses which are just running perhaps Active Directory, or maybe some of their SharePoint infrastructure, or, you know, whatever Microsoft workloads that they might have, comfortably running those on AWS. When it comes to SQL Server, we have a similar story. We enabled you to be able to use SQL Server 2018 R2. And subsequently, as new versions of SQL Server have come out, we've made sure that there's been machine images to allow that. We've also added support for a managed service. So if, for example, in AWS, a lot of our customers previously would have got some EC2 instances together and maybe installed SQL Server, and then created high availability with a couple of servers, and they would have to manage all of that infrastructure themselves. We recognized this pain point, so developed a thing called RDS, or Relational Database Service. And we have a database service for lots of different types of database. So there is a relational database service for Microsoft SQL Server. And basically it means that you spin up a RDS service and you're able to start using SQL Server. And if you click a box, you can say, I want a high availability version, which means that we put it over a number of different machines and use and support the Microsoft SQL Server high availability feature. So there's lots of stuff that we've done around SQL Server as well. And then when it comes to .NET, the very first AWS SDK, which was around 2008, 2009 sort of timeframe, was our very first complete SDK. So there were SDKs prior to that, but that was the very first one which covered all of our services at that time. AWS currently has over 180 different services, all addressed by the SDKs. But the .NET SDK back in 2008 was the very first SDK that we built. Now we have SDKs in .NET, we have them in Python and all different languages, obviously. But the .NET one is the very first one which we had. And subsequently, we have added lots of support for .NET things over the years. So we have things like the ability to build .NET applications using Cloud Build, which is our CI/CD pipeline. We have things like X-Ray, which are a way of logging inside of your .NET applications. So we built a library called X-Ray and provided .NET support for that. We have a serverless feature called Lambda, AWS Lambda. We added .NET support for that. And every time .NET is released, we update that Lambda support. So currently we're supporting .NET Core 3.1. And when .NET 5 comes out, hopefully this month, we will have support very quickly for that too. We also have a thing called the .NET Developer Hub on AWS, where you can go there and it just explains, all the different things that are available for .NET. And so we added that very recently. And then all of the things for modernization in the .NET realm, we've added support. So we've got things like Windows Deep Learning AMIs, so Windows Deep Learning Amazon Machine Images. Those machine images are used by lots of companies. Just Eat, that I mentioned earlier, are actually using those Windows Deep Learning AMIs to build deep learning models and artificial intelligence stuff for their websites and applications. Yeah, we keep on introducing new features and new support, and trying to make sure that .NET developers can reach and use and get the value out of all of the different services that we have at AWS. And there are a lot of different services at AWS. There are, as I mentioned, about over 180. We used to count them and we used to announce them on stage every year. The last time we ever did that was reInvent about 2 years ago, when we had 165 plus services. But we started realizing that it's probably not, it can put people off to say I've got 180 services, because they don't know where to start. And it can be extraordinarily confusing when you come to AWS and you see 180 different services and think, gosh, like, where do I start? Where do I begin? If I'm a beginner and I need to learn this, like, what do I do? And that was pretty much how I felt 2 years ago when I joined AWS and was promised that they'd tell me and teach me about AWS. I was just overwhelmed by how much stuff you could do. And some of it's obvious and you expect it to be there. So EC2, for example, you expect the ability to run instances and virtual machines. But then some of the other things are a little bit more complex and confusing. You have things that you might want to use, like Lambda to run serverless, AWS Lambda to run serverless functions. You might have things like S3 to store objects in. But then you've got other things like the machine learning services, the AR, VR services that are a little bit more out there and left field. Then we have quantum services. So we have quantum computers that you can rent and use and run code on. We have blockchain services, and we even have a satellite ground station. So if you are in the business of requiring speaking to your satellites in orbit, then we actually have a ground station service as a service for customers which want to do that. And now, I'm not suggesting that every .NET customer wants to use ground station and speak to satellites, but we recognized there was a customer demand, so we built a service around that. And we have over 180 different services which service all kinds of different customer needs. The biggest problem is, though, when someone starts and they look at this, it can seem overwhelming. But the reality is you kind of need to know a few or a handful of services at AWS to really start using it properly. And if you're trying to build regular kind of applications, regular kind of websites, regular kind of WPF applications, then AWS, there is only like probably 5 or 6 different services that you'll really need. And then some of the other services you could potentially use or you could bring in, but there are core services, or we call them foundational services, that are really important to understand. And then the rest you can learn over time. So you'll find when you're learning AWS, if you're interested in sort of going on an AWS journey, then training partners like A Cloud Guru will take you through foundational services first, and then they will expand into some of the more specific or niche technologies, which can do extraordinarily powerful things and are really important for certain customers, but not important for everybody. So if you think about all of these services, what are they doing really? They're enabling you to build infrastructure in the AWS cloud. And so there are a number of ways of building things in AWS. The first and the most straightforward way is when you go to I want to search for something like Amazon S3, and I've heard about S3 and I want to store some documents and some images and some videos in the cloud somewhere. Amazon S3 is the most popular storage system on the planet. It's one of the largest systems on the planet as well. And it's basically a place where you can store objects. You will have undoubtedly seen S3 links if you ever receive an email from any company where they've got a PDF that you want to download, or you might have seen it in linking to images on websites, or which is included in emails. And hundreds of thousands of customers use Amazon S3 to store their images, their videos, and PDF objects and things like that, so that they can use them in their applications and distribute them to their customers. Now, if you wanted to start building with S3, the thing you need is a bucket. And a bucket is like a thing where you stick all of your objects in. And we can create these buckets a number of different ways. And I'm going to show you all the different ways that you can create a bucket in AWS. And it kind of exemplifies how you go about using any service. So this is just one service and how many different tools or ways that you could build that service. So this first and most simplest one is the S3 management console. At AWS, we call our website a console. So other cloud providers call this a portal. Some web providers call it a website. We call ours the AWS console, which I was confused by actually when I first joined, because console to me felt like the name that I sometimes call a terminal or command line. So when everyone says you just go into the console and do this, I thought that they meant go to the CLI and start doing it in command line. But no, the console means the website, and most of them look very similar to this. We follow a design pattern now. So all of the services are trying to look the same. There are still services there which look a little bit different and have a slightly different look and feel, but most of the this has a very consistent look and feel nowadays across all of the different services. You navigate on the left, you take actions in the middle, and there's generally buttons which are bright orange which can do things. So if I wanted to create a bucket here, I'd press the bright orange create bucket button, and then I would be able to enter a bucket name, and then that bucket would be created for me. And by default, that bucket won't be accessible from the internet. It will only be accessible from within your account. And so only maybe EC2 instances which exist in your account could actually see that. But you can have the option to make some of these buckets public, or some of the objects inside of these buckets public. So let's say you were going to be using this to store all of the assets for your website. You could create a bucket and then have a certain folder in that bucket, which would be have all of your assets for your website. And then you would perhaps put a CDN or content delivery network in front of that, which is just again, we have one of those as a service. You put it in front of your S3 bucket, and then you would use it on your website. And pretty much, if you're building a large globally distributed website, then you will almost certainly be using S3 somewhere. All the major top 100 websites will be using S3 pretty much. It's a very popular service, and it serves tons and tons of objects. We don't. I think it's 9.99995 or maybe even 6 nines of durability. So anything you put in S3 is not lost. Yeah, it's a pretty stable and reliable service. Another way you could create a bucket, though, would be at command line. So we call this the AWS command line interface. It's actually written in Python, but you're obviously just issuing bash commands to it. This is a really popular way for operators to interact with AWS. And most scripts are written in bash, directly calling the AWS command line interface. This, when we build a service at AWS, is almost always the first thing that's built. So I work on the AWS news blog with Jeff Barr, our chief evangelist. And we every single service release that we have at AWS is blogged about on the AWS news blog. And what we have to do is use the service, then we demo it, we write a little bit about it, we have to write a demo for it, and then we put that on the AWS news blog with every service. Whenever a service team comes to one of the authors of the news blog and says that they've got a new service that they're going to launch in a couple of months, pretty much they will have the command line interface ready for us so that we can test it. And then probably about a month before launch, they will have the console ready. And so those two things are generally always there from launch. So you always have the command line interface and you always have the console experience. We never would release a service without those two things being enabled. And the command line is pretty straightforward. If I want to use this to create a bucket in S3, I would go over to my command line. I use a Mac generally, but it would be very similar on Windows, where I'd say AWS S3 MB for make bucket, and then I give a URL, which is demo terminal S3 bucket. I give it a region, -- region EU West 2. There are multiple regions in AWS. EU West 2 is one of those regions. This is where that bucket's going to be created. And then it will return make bucket, and it will basically echo back the name of the bucket. Now, it's exactly the same as of creating in the console. So I can create it in either the console or in command line. And obviously, if I want to work with it, I could upload stuff via the command line. I could delete buckets. I could change the permissions on those buckets. I could change the public. All the things that you possibly can do can be done through the CLI. Now, for a long time now, we've had support for PowerShell, and we currently support PowerShell and PowerShell Core, and PowerShell 7 we support. So we have a whole framework for PowerShell, specifically because there was some customers which preferred to use PowerShell versus the CLI. And so we developed a PowerShell library. Now, previously, it was one big monolithic library. Now, what you do is we've split every service has its own module. And basically, you can import the modules. We have one base module, and then you can import modules to build scripts and PowerShell scripts. So the PowerShell tooling to make a bucket is pretty similar. So if I go into a PowerShell command line, I can just write install module. So this is the AWS Tools Installer module, the base module, which allows us to install other modules for AWS. And then I'm going to use S3. So I install the AWS Tool module S3. And then I say new S3 bucket, provide it with a bucket name, provide it with a region. In this instance, it's EU West 1. And then it creates that bucket and it returns me the bucket name. So like I've done the same thing in all those different ways. All I've done is created buckets, but this shows you that you can do it now with console, CLI, and PowerShell. There are more ways. One of the really common or popular ways to start creating infrastructure nowadays is through code. And we have a system called CloudFormation. If you're more familiar with Azure, it would be similar to ARM templates or Terraform, which is the ability to create infrastructure using YAML and JSON. So you describe it in a YAML file. You say you want a bucket, you want maybe an EC2 instance, you maybe want a load balancer, you want network configurations, you want a virtual private cloud. You would create all that into a YAML or JSON file, and then you'd be able to check that in and create your infrastructure via a sort of document. And customers really like this procedure because it means that every time they edit the file, it would edit the actual infrastructure they have in the cloud. It means that they have source control over the way that they create infrastructure, and they can see when changes have been made against their service. Now, CloudFormation is great, and it's very, very popular amongst operators and IT professionals who, kind of like YAML or like JSON as a way of configuring cloud infrastructure. But we had a number of customers telling us that they were developers, especially with this sort of DevOps movement. There are a lot more developers which are involved in the creation of infrastructure nowadays. And so we created this thing called the AWS Cloud Development Kit, which enables you to, instead of writing it in JSON or YAML, you write it in a supported language, and it will ultimately compile down into YAML or JSON and use the CloudFormation service under the hood, but you write in the language which you prefer. So you can write in Python, Java, TypeScript, JavaScript, and there's a couple of other ones in the works. The one that we're obviously going to be looking at today is C#. So we have C# support. So the way it works is you basically create an application, and it has there's a handler in there which says to create a stack, and then it really is just a console application. But these classes that it inherits from, the stack class that it inherits from, is a CloudFormation stack, and then we just write, say, new bucket, and I pass over the ID of the bucket that I'm going to create, And I could save that bucket name into a variable. And then when I'm creating other infrastructure, I could give that infrastructure access to that bucket, for example. I could put a for loop in there and create multiple buckets. It's a programming language, so I can build my infrastructure in a programmatic way rather than through a command line interface. So the CDK is proving really popular nowadays, and that would be how you would go about building your S3 bucket in the cloud development kit. When you build your application, so if I wrote this code, it obviously doesn't, as you're writing the code, it's not changing the infrastructure. That's not how it works. You actually then have to go into the folder where this application exists and run the command cdk deploy, and it will then basically compile the application, run the application, and then deploy the output to the CloudFormation service, and then instantiate the cloud. It will instantiate all of the different assets and resources that you defined in your application. It will start building them. Now, it's quite common for people to build. Whenever I demo stuff, I will often build a CDK application and deploy my application from that. But more commonly, it's used inside of a CI/CD pipeline, where someone will, a developer will just check that code in, and then the cloud development kit will either reprovision the application based if there's been changes to the underlying infrastructure, or maybe deploy the application depending on how it's been put together. But this can be used as a sort of tool which a developer uses on their laptop to go and create cloud infrastructure, but it's more commonly used in a CI/CD pipeline. Now that's creating infrastructure, creating S3 buckets. I've shown you lots of different ways to do that, or creating EC2 instances, or creating a Kubernetes cluster, or whatever you might want to be creating. But then how do you interact with AWS? Well, I've talked about it already, the SDK that we have for .NET. So we have the AWS SDK for .NET. Basically, the SDK is one core NuGet package called core, and then every service has its own NuGet package. So if I was wanting to deal with S3 from the SDK, I would go and import the NuGet package for S3, and I could start interacting with S3. Now, obviously, with the AWS SDK, you're not going to be using that probably to create buckets. You could, but you're probably not using it to create buckets. You're probably using it to store stuff in buckets, or retrieve things from buckets, or maybe interact with a database service or something like that. So for example, here's some code where I've got a console application, and I've got a couple of things that I define up the top on lines 10 through to 12. I'll define a bucket name, a key name, and an endpoint or a region that I'm going to go to. And then basically when the console application goes into the void main or starts up, I new up a Amazon S3 client. I pass in the information about the region that I want to go and connect to. And then I call the asynchronous object to go and basically put a file, which is local on my disk, into S3. Now, this is a kind of useless application, but it just goes to show the kind of interactivity that you can have with any AWS service. So I've got a put object request here. I'm providing the bucket name, the key name, the content body that I'm going to provide, and then I ultimately say with the client.put object async, and I put my put request there, and it will write that file to my S3 bucket. So there's lots of capabilities in this SDK, and the SDK covers all of the different services. So whatever services that we have, you might want to interact with, you would do that using the SDK. Now, it's all good and well having an SDK, but we recognize that to be productive as a developer, you've got to have good tooling as well. And so we have tools for many popular IDEs. So if you're a fan of Visual Studio Code, we have the AWS Toolkit for Visual Studio Code. And this allows you to, it has a number of different templates for you to build from. The one which is for Visual Studio Code will let you do things with your account and interact with your account from within your IDE, but it's generally focused around serverless applications. So if you're interested in building AWS Lambda, then this toolkit really helps with that, and will give you the ability to deploy applications really simply from the IDE, to debug them locally, to debug them without connections to the cloud. If you're on a train or on an aeroplane like we used to do, you can debug your applications that way. So the toolkit for Visual Studio Code has been out for over a year now, and is becoming really popular. We also support another IDE called Rider by JetBrains. You might not have heard of Rider. I love it. It's my IDE of choice at the moment. It's particularly good if you're working on Linux or Mac, because it's a cross-platform IDE for C#. If you haven't heard of Rider, you might have heard of JetBrains, the company which make Rider. They're also behind Resharper, which is the really cool sort of productivity tool. And Rider is very similar to, it's basically it's an IDE built by the Resharper team. So it has some really, really cool features. One of my favorite features in Rider is the ability to directly debug closed source libraries. So it basically has a decompilation engine which allows you to set breakpoints in, you can dive into code that you don't have the source code for, and they have this way of decompiling the application and then allowing you to sort of step through third-party code. And it's really helped me. There's been lots of instances over the last couple of years where a customer or someone has a DLL, but they don't really have the source code, but it's causing a problem. And I've been able to resolve the issue by sort of diving it. Anyway, it's a great IDE. It's got some really powerful features, particularly with debugging, and we have a support for that as well. So it means that when you install the add-in, you can start doing things with your AWS account. Again, this one is particularly good if you're building serverless applications with AWS Lambda. It means that you can deploy them directly from the IDE. You can debug them locally. You can test them. But most of our customers, they use Visual Studio. So they'll use Visual Studio 2013, 15, 17, or 19. And we have support for all of those versions of Visual Studio. And this is a much more complete toolkit. It's not just for serverless applications. It's for pretty much all of the services that you're likely to need as a .NET developer in AWS. And it's a very complete, and it's our sort of gold standard of tooling. The way that you install it is it's an add-in for Visual Studio. So you just go over to the the Visual Studio Marketplace, and you search for AWS. And we'll come up there as the top result, or we should. And you can see this version's had a 1.2 million installations. This is the version for 2017 and 2019. We also do have a version for 2013 and 2015, but it's a separate package. You download the V6 package, which is the update system, the add-in system for Visual Studio. And you can click on that, and basically it will install the add-in for you inside of Visual Studio, whatever version that you're using. From there, you have a number of things that light up. And the most common one which people will start to use is a thing called the AWS Explorer. So this is the AWS Explorer. It's over in the View menu. You go down and click AWS Explorer, and then it shows you what account that you're using. So you can have multiple accounts or multiple credentials which link to different accounts. You can add different account profiles from within Visual Studio, and these are shared. If you use the CLI, you'll be sharing these. They're not kept creating separate ones. So if you've already used a number of profiles in the CLI, those profiles will be in there. And you can interact with services. So DynamoDB is a NoSQL database. You can create it and edit it and do it from the CLI. You could do it in lots of different ways, but we can now also create a table in DynamoDB from directly within Visual Studio using the AWS Explorer. So this is a kind of the ability to work with all these different services. So I've just added a table with a name column and a Jeff column. And I say, Martin, is Jeff? No. And I'll put Jeff, yes. This is me doing Booleans with strings. It's not the greatest example of building databases, but it just goes to show that you can edit a DynamoDB directly from within Visual Studio. I could maybe look across a DynamoDB table. I could look and see what's in it in the application. So I've given some names and some ages to that. You can do a scan table. A scan table in DynamoDB is like a search. So we can say when name string equals Jeff, and then scan the table, and it will return 1 row instead of 3. Or we could do something like because it's equal, it's not coming back. If I change it to contains and then scan the table, it returns that 1 row, Jeff 35, and he is a Jeff. You can create EC2 instances from here. We can create S3 buckets if we want to. We can create all sorts of different infrastructure directly from within Visual Studio. We can even manage some of the security. It has a basic security ability, so we can create a user in our AWS account from within Visual Studio. So we had a user called Jeff, and then change his permissions and his access keys and things directly from within Visual Studio. Now, when I joined AWS, I'm really a web developer. So I was like, well, how do I publish a .NET website in AWS? What's the simplest way? And someone told me AWS Elastic Beanstalk. That is the easiest way to run a website in AWS. It's a service that's been around since 2000, I think 2010, 2011. So it's got some history, this service. And it kind of was one of the very first non-infrastructure based services at AWS. And the idea is that you give us your code, and then we will take that code and we will run it across a number of machines, and we'll provide a load balancer, and then you can create a load balanced web application. And Elastic Beanstalk works for Node, for Python, for lots of different web technologies, but it also works for .NET. We have support for Windows.NET, so the full framework .NET. So if you had an ASP.NET 2 application, you could run it on Elastic Beanstalk happily. But we also have support for Linux on .NET Core. So if you have got a .NET application and you want to save money on Windows licenses, you could deploy that to a Linux machine instead of a Windows machine, and that would obviously reduce your costs to some extent. Elastic Beanstalk also supports Docker containers, so there is a way that you can run containers directly onto Elastic Beanstalk as well, although it's not. There are better ways to run containers on AWS, but it is one way that you can do that. So let's just say, okay, I want to create a website and I want to go and publish it to Elastic Beanstalk. How does that work? How do I go through that process? Well, it's quite straightforward, especially if we're using the Visual Studio tooling. So let's say I want to go into File, New, Project. Now, because I've got the toolkit installed, if I were to search for AWS templates, you'll find there's a number of different templates there that I could use and I could work with. Serverless Lambda ones, CloudFormation ones, all sorts of stuff for C# and F#. But I'm not going to use an AWS project. I'm going to use a standard .NET Core project. This is actually a very old .NET Core 2.2 web application. We'll call it Web Application 6 just to be interesting. And then we say, what kind of application do I want? I just want a web application. I'm going to go and create that. So this is nothing to do with AWS at this point. It's just a standard website. But because I've got the tooling installed, if I right click the project, it says publish to AWS Elastic Beanstalk. So I click this button and it says, okay, in your AWS account in that region, you don't have any infrastructure to support this at the moment. So you're going to have to create a new application environment. I give my application a name, so Web Application 6. I've got a number of different environments. You can do things like blue-green deployments, canary deployments. We're not going to go into that. I choose the container type, which is going to be, let's say, Windows Server 2016, IAS 10. I choose my instance type, which is like the size of the machines that I want it to run on. So I say T2 micro, which is a very small machine. And then I create a security key pair, which is going to allow me to, I'm never told what the username and password is for these machines. But I do have this key pair, which allows me to generate the username and passwords for that machine. It also asks me to attach a role to the instance. And that role is how that instance has security clearance to call other services inside of AWS. One of the biggest differences between AWS and other cloud providers, in my opinion, is the way that it manages security. Everything's done through these roles and policies. So if you create an EC2 instance, you attach a role to it, and then that role is how you then assign permissions to talk to other things. So to give you an example of that, I created a Redis server or a Redis cluster to do some caching. And in let's say Azure, what you would be given is an endpoint for that and a username and password for it. Well, that's great, and you can connect with that. But what happens when I created a Redis cluster in AWS was I was just given the endpoint, and it confused me somewhat because I was like, well, I don't have a username and password. How am I going to talk to this Redis cluster? You very rarely get API keys to speak to services or usernames and passwords. What you have to do is assign an IAM role permission to speak to that service, and then you give the EC2 instance or the Lambda function that role, and then that role has permission to go and speak to the service. One of the advantages of this is that you can have like 10 machines all sharing the same role, and therefore all sharing the same ability to call the same services. So it simplifies when you have like lots of machines managed. You can basically centrally control the security for that through a centralized role. Obviously, machines can have individual roles, but you can share them as well, which makes things easier. Now, to show you what Elastic Beanstalk is a slightly unusual service in when people look at it sometimes, because I said when I created my application that I wanted to create I can't remember what I actually chose, but let's say I said I wanted 2 servers load balanced. It would go and create 2 EC2 instances. It would deploy my application code on there, and it would manage it. If for whatever reason one of those servers stopped responding, it would recycle that machine, restart it, redeploy the code, and manage it for you effectively. Now, a lot of other companies, the way that would work is that the machines would be outside of your account and you wouldn't really be able to see those machines. But with Elastic Beanstalk, it actually is creating those EC2 instances inside your account. So if you want, you can actually go and have a look at the underlying infrastructure which makes up your Elastic Beanstalk service. So I said that I wanted a machine and a load balancer. So what you can do through Visual Studio is say, I want to connect to one of the instances which run this. So there's by the way, the URL for my website, which was deployed. And you can see that it's just a .NET application and it's running as you'd expect. There's a little option here to connect to the instance. Now, I don't have a username and password for any of these instances, but I do have the key pair. So I'm going to provide the EC2 key pair here. But it's saying that port 3389 on the machine that I'm trying to connect to is blocked. And if you know RDP, the remote desktop protocol, that's over port 3389. So I can't communicate with it. So what I need to do is unblock that port. Now, to do that, we use a thing called security groups. Now, security groups are a little bit like firewalls, but a firewall usually would be per machine. So you'd have a firewall on each machine, and you would go into each machine and you would open port 3389. With AWS, you have this thing called a security group, which a single security group can be applied to multiple machines. And you can say on that security group, open port 3389, and it will basically open the port for all of the machines that it's attached to. And so if you're in a load balance scenario where you've got lots of different servers, which maybe they're being replaced or coming back up, if you say you want them to always use a particular service group, a security group, you know that they'll always have the ports that you want open. So that's what a security group is in AWS. It's basically a shared firewall. I don't think that they'd like me to describe it like that, but that's how I think about it. And so I want to go and add the RDP ports to that security group so that I'm able to go and remote desktop into the machines. So you can do it from within Visual Studio. Go to the AWS Explorer and go into the security groups inside of the EC2 section. Go to the security group that's attached to my Elastic Beanstalk instances. And I can say, I'm going to add a permission so that, and they have some pre-filled ones in here. I can just say RDP port 3389 is open. and basically that will open that port. I've only got port 80 opened. I can open the outbound permission as well. I don't think I actually need to, but it shows you the outbound ports can be done as well. And you can scope these ports so that they're only accessible from like internally inside of your account, inside of your virtual private cloud. You can make them non-public ports. There's lots of different options. You can say only accept incoming requests from certain IP ranges or certain specific IPs. And there's lots of ways that you can secure services using these security groups. But the cool thing is every server that uses this security group, and everyone has to have at least one security group, they will all now be updated to have port 3389 open. So I can go back to the controls here and say I want to connect to that instance. I'm going to log in with my key pair. Under the hood, it does some API magic to generate the password and username to log me in. And then, as you can see, it's a regular, I chose a 2016 IIS 10 instance. I'm not suggesting you ever would go into Elastic Beanstalk using RDP, but I like to show it just so that you know under the hood, it's nothing magical. It's just Windows, which we're running under the hood there. So there we have got a Windows machine running and it's deployed my application. So that's how it works. Now, so Elastic Beanstalk, it's one of the easiest ways to deploy an ASP.NET website or a .NET Core website. Another option is through containers. And if we wanted to take that same or a similar website and add container support to it so that it runs on Docker, we could do that quite easily. And once it is a container, it supports containers, then we are given some other options to be able to deploy it to AWS. So if I right click this project at the moment, you'll see that it only has the ability to publish to AWS Elastic Beanstalk. It doesn't have any mention of a container because there's no Docker file in this application. So if I add Docker support to this application and say I want a Linux container, I could choose Windows if I wanted to. What that will do is add a Docker file to the root of my project. And this has been created by Visual Studio. And it points to a Docker file which will build and run. But now I have this new capability which says publish container to AWS. Because it's seen the Docker file, it knows that this is a container application. So now I can either publish this directly to ECS, which is our Elastic Container Service, or I can publish it to the Amazon Elastic Container Registry. And this is a little bit like Docker Hub, but a private version of Docker Hub. And it means that you can deploy it to the ECR or Elastic Container Registry and store that image and share it with your dev team or your the other people in your team so that they can then go and ultimately deploy it to production. So we could either publish it directly to ECS, to our container service, and it will run our container, or we can publish it to the container registry where we're just basically publishing the image so that other people can use it. Now, when it comes to containers and .NET, there are a number of AWS services that can run containers. The oldest one is called ECS, the Amazon Elastic Container Service, and it's extremely popular. It was one of the world's first publicly available container services, and many customers use ECS at AWS. It's one of our biggest services, and you can run any kind of container on ECS. You can run .NET Core on Linux, .NET Core on Windows, or .NET Framework on Windows. So you can actually run either Linux containers or Windows containers. And you can even, if you have full fat framework, .NET Framework containers, you can run them on Windows, as well as the standard sort of Docker Linux containers. reInvent last year, our big conference, I did a whole session on showing you how you can containerize legacy .NET Framework applications and also new .NET Core applications and deploy them to ECS. It's a really popular service. As I say, lots of our customers use it. There is a new kid on the block, though, an open source alternative called Kubernetes, and we have a managed Kubernetes service called Amazon EKS. It's the most popular Kubernetes service in the world, and it's highly available, highly scalable, and it has some really cool. We have some really cool features with EKS, which I'm not going to go into. But just to say, you can run Linux containers, also Windows containers on our version of Amazon EKS. We've recently added the support so that you can run Windows containers on there as well. There is another way of running containers. We call this AWS Fargate. Now, with ECS and EKS, when you create a cluster, what it actually does is both of these technologies create nodes effectively in your account. And these are EC2 instances. And then those collection of EC2 instances are what makes up your cluster. And when you deploy a container, the container scheduler will place that container on one of those instances. And basically that all where it places it is all based upon, you know, the inner workings of ECS and EKS. But you actually have physical machines or instances in your account which make up your cluster. So some customers will have like 3 machines. Some clusters will be made up of hundreds of machines, but they exist inside of your account. So if you go to your EC2 dashboard, you will actually see the machines that make up your cluster, and you'll see them as physical machines that you can stop, restart, delete, deploy. And that's cool. But it means that you're always paying for them. So you're always paying for them. You've got a container deployed to them. You're always paying for all of the infrastructure. Now, we have another service called AWS Fargate, and that actually sits on top of either EKS or ECS. You can run it on either service. But instead of the pool of servers being available in your account, it's actually in our account. And this means that you only pay for the time that your container's running. Fargate is, in my opinion, like the best way of doing containers, because you don't really want to manage the servers. Some people call this the serverless container platform, because you can run your containers without managing any of the underlying infrastructure. And certainly from an ease of use point, Fargate is by far the easiest way to create containers. So yeah, those are a number of different ways of creating containers. You've seen from within Visual Studio how to take your application and make it into a containerized application, and then you can deploy it to one of these services. And those services are quite complex, and it took me a while to get familiar with them. I just wanted you to be aware that that's what those 3 services are. They might be useful to you if you want to do containers. So let's just look at a little bit, like shift over. So we've shown you basic Elastic Beanstalk, which is a much traditional way of, quite a traditional way of hosting an application or a website. Then you've got containers, which is a very a more modern way of doing a very similar thing, really, of containerizing your applications, then running them. To then sort of shift to the really modern stuff, which is serverless, and how you would run serverless.NET applications and workloads. This is a service called, it's an AI artificial service called Recognition. And it can accept images and videos, and it can do all sorts of cool things with it. So you can find faces in images, you can find emotions in images, you can label images or videos. For example, you could upload an image, like on the left here, of that gentleman on a bike, and it will be able to label what it can see in the image. So it says that it sees a person, a crest, outdoors, mountain bike, rock. It sees all those different things, and it can label them, and it gives you a score, a confidence score, as how likely it thinks that it knows that it's got a 99.3% certainty that is a person in that image, whereas it's only got an 83% certainty that it's a crest. That's called the labeling service. It's one of the features of Recognition. There's lots and lots of features that I won't go into, things like handwriting recognition and text recognition and object recognition and facial recognition, celebrity detection, sentiment analysis, all sorts of things. So if I upload an image to it, and this was one I was doing today because I was doing a similar talk in Italy. This is the Royal Palace of Caserta, and it's a Royal Palace in Italy. And if I took that image and uploaded it to Recognition, it would be able to label that image with what it can see in that image. So it would see things like, you know, that it's a building, for example. Now, let's combine a serverless Lambda function with an S3 bucket and this AWS Recognition service to create a very simple labeling service. Now, this sort of thing is used, these sorts of applications are used by companies that want to ingest information from their customers. So Instagram is a good example of this, that they want customers to upload their pictures of them, skateboarding or whatever the cool kids do on Instagram these days. And what Instagram do is that they pass it through a similar AI service and will label the image so that they can make it searchable, and also that they can categorize it. And also it can run it through filters like nudity filters or obscenity filters to make sure that the image that's being uploaded isn't obscene or contains nudity. So there's lots of things that like a service like AWS Recognition can do. The labeling aspect of it is really useful for categorization and searching. And it's also, I've used it, for example, on websites where I've got user created content that I want to then provide descriptions for accessibility reasons. So if I want to provide an alt tag on a website for the images that are uploaded, you can do that using a service like AWS Recognition, where you basically find all the labels inside of an image, and then you go and make a meaningful alt tag for that image. So if I want to create a system like this, I might use S3 and AWS Lambda to achieve that. So what we're going to do is we're going to create a Lambda function and basically an S3 bucket. Now the S3 bucket is going to accept objects. And if an image object is uploaded into S3, S3 is going to go and trigger a Lambda function. That Lambda function is a small piece of code which has one job. And that one job is to take the image which has been passed to it, and it's going to look at it, pass the information over to AWS Recognition. It's going to label everything that it sees in the image. And then I'm going to take those labels, and then I'm going to go back to S3, and I'm going to write it on the object as metadata. So inside of Visual Studio, if I choose one of the AWS templates, and I could choose an AWS template with tests or one without tests. Let's do one without tests. AWS Lambda project in .NET Core. And I give the project name S3 upload and create. I can choose a number of blueprints. We actually have a blueprint for this application called Detect Image Search. And this is basically our application. We've got a S3 upload. Now, I'm not going to show the application at the moment. I'm just going to publish it directly to AWS Lambda. Now, you'll see that that's very similar to publish to Elastic Beanstalk. But because it's a Lambda function, it's saying that it's a Lambda project. I give the function a name called S3 upload. I give this a role, which is the security role, which it's going to be using to connect to other services. And then I upload that function. It's going to deploy it. Now, if we explore what's in this application, basically there's an entry handler or a handler which handles the event when something's added to S3. So here we have an approximation of the function handler. And it's got some inputs. We've got an S3 event input and an I Lambda context object called context. Now, the input object is going to contain a number of the input object is going to contain a number of properties and things, but it's going to tell me what S3 objects initiated the Lambda. Excuse me. Now, it could have been a group of records. There could be more than one object. So I'm going to put a for each loop in here to loop through all of the records that were input. And this is basically looping through all the files that might have been uploaded to S3, which triggered this Lambda function. And then I've got a little bit of code which says inside that for loop, which says if the image is an object, an image object type, and it's one of the ones that I support. So if it's a JPEG or a PNG, then I'm going to continue. Else, I'm going to write object is not supported. It's not a supported image type. So if they upload a PDF to the S3 bucket, it's going to come here and it's just going to exit the Lambda function because it's a PDF thing, and I don't currently support PDFs. I only support certain image files. And then if it is a supported image type, it will get to the next stage of the code, which is basically using the SDK for the AWS SDK, and it's using the Recognition NuGet package. And in that NuGet package, I have a thing called a recognition client. And it says await.this recognition client detect labels async. So the recognition client, there's lots of features inside of recognition. One of them is detect labels. So I say detect labels async, and then I create a detect labels request. I provide a minimum confidence. So I want to basically generate labels above a certain threshold. So I'll say, if you're 70% sure then that it's actually seen in the image, then add that or return that as a label. And then I create a new image, which I pass in to the detect labels request. And this new image is constructed from an S3 object, which was passed in. And I say, create a new image from that S3 object and pass it over to recognition. And what I'll get back is a list of all of the tags, or all of the labels, sorry, that have been associated with that image. So what I do is I then create a list of those tags. So I'm just using a string of tags, and I for each the responses. So all of the labels that get sent back to me from that image, I will come back to. And because for simplicity, I only want to, there is a limit to how many tags that you can add as metadata to an S3 object. So I just say, for convenience sake, only include the top 10 tags that were found in the image. So basically it will find it comes back in order of the percentage order. So the top 10 should be the top 10 things that's found inside of the tags. And basically I then construct a list of these tags. Now, once I've got the list, I then go back to the S3 client and I say, put this object, this tag, these tags back onto this S3 object. So attach it as metadata to that image. So it adds it as these tags here. So an S3 object can have certain metadata properties about what that S3 object is. You can think of it like a file, I guess, and on all of the different properties on that file. And these tags are a way that you can then add it to the S3 object. Then any basically application which is using that S3 object can not only go and get the image, but it can also go and get, the tags associated with it. This is useful rather than having to go and store this in a database somewhere, because I don't have to have a separate database for this. I can just store it along with the image inside of its metadata. So that's all good. But the thing when I run this is that the Lambda function will fail. And it will fail because the Lambda function does not have permission to speak to the other service, to the recognition service. So I mentioned earlier, security in AWS is all based upon IAM roles, or IAM roles, IAM roles, identity and access management roles. And IAM roles need to have given to the Lambda function or the EC2 instance, and then they need to have permission to go and speak to the services that you need to speak to. So I need to go into the role that's attached to this Lambda function, and I need to basically give it permissions to speak to recognition. So the way that we do that, if we go into IAM and look at the roles, and I search for the role that I attach to that particular function, it was actually created called Lambda X S3. And then I search for a policy. Now, these are predefined policies, but you can create your own as well. And I say Amazon recognition full access. Basically, now that Lambda function has full access to the recognition service. You might want to provide more granular service. Maybe it can call certain features inside recognition, but not other features. You can do that through this system as well. But now that Lambda function, or any Lambda function that uses that particular role, that now has the ability to speak to recognition. So I'm going to create a bucket, an S3 bucket, and then in the Lambda function, I'm going to make that the event that goes and fires my Lambda function. So you'll see I've got over here on the left-hand side, the ability to create an S3 bucket, and I'll call it a bucket for the Beebs. Create that. And then in the functions property, I can go to the event sources for that Lambda function. I can add an event source, and I'll say the source type is S3 and the S3 bucket. Click OK. And now my S3 bucket and my Lambda function are linked together. So basically that function will be called anytime something's added to that S3 bucket. And you can be more specific about it, but I've just said anything which goes to that Lambda function is going to invoke my Lambda function. Anything which goes to S3 bucket is going to invoke my Lambda function. And what I can do now then is upload to the S3 image. Now, I could upload that image via CLI. I could do it through PowerShell. I could go to the console and upload the image. I can also upload to the S3 bucket from within Visual Studio. So I can go to the S3 object. I can say upload a file, choose my demo image, upload it. You'll see that there's no tags on that image. I upload it. If I right click that image, now I have some tags on that image, and you can see that it's got building, architecture, palace, mansion, clock tower, house, tower, city, housing, and the various values and associated with them as well. So I've attached those tags to that particular S3 object. Now that's an example of a single serverless function and able to work with other services. But applications, Lambda serverless applications, are really quite cool in that they don't have to just be a single serverless function. The reason why something like that's quite interesting, in my opinion, is because every time that image is uploaded, my Lambda function is fired and some compute is expended. I'm actually only ever charged when we use compute. So if no one ever uploads anything to an S3 bucket, I never pay for any compute. But if someone uploads something to S3 bucket, it will initialize my Lambda function. My Lambda function then goes and does something. That will be then charged just for that execution. In AWS, you get every month 1 million executions free, and then you pay for any subsequent executions. So you can build a system like that and maybe only use it, a few thousand times a month, maybe a little personal project or whatever, and you won't actually ever pay for that. If it's starting being used more, you'll obviously pay per execution, and you pay per the amount of memory that you're using and the amount of compute that you're using. And it's billed per per 100 milliseconds. So you only ever pay, it's paid not by the second, but per 100 milliseconds. So if you build something and it's unpopular, you don't really pay for the infrastructure. And if you build something which is highly popular, you only pay for what you use. That pay for what you use is really powerful. So one of our customers, Comic Relief, so the charity, they have this workload where for one night a year, their website is extraordinarily busy when people want to donate to them. And then for the rest of the year, it's really quiet. And so they thought, do you know what, serverless would be really valuable for us because, we have these spikes in demand, which something like Lambda is also really good at dealing with because we maintain all of the banks of servers which actually have to run these functions, and we have huge scale. So we can handle, massive spikes in compute which are required from it. We will build new machines and so forth, on demand. But you as an end user, you don't have to worry about any of that capacity like management or guesswork or anything. You can just scale and spike out and use Lambda in that way. And you're only paying for what you use as well. So if it's not being used, you're not paying for it by definition. So Comic Relief rebuilt their traditional web application. This was last year, and their hosting charges for the month where they usually have the telethon is around, I think, $85,000 a month. And they reduced their bill that month to, I think, somewhere around £7,000. It was pounds, not dollars, obviously, because they're a UK company. They basically reduced their costs by 93% for infrastructure, whilst massively increasing their scalability and also not having to manage any of the infrastructure themselves. If you're interested in that story, there's a great talk that one of the development leads did from Comic Relief at our reInvent conference, and she explained all the details about how they became a more resilient company, but also how they made this massive 93% saving just by re-architecting to use serverless. So serverless is a really powerful paradigm for building highly scalable, cost-efficient systems. But they don't have to be just single functions like I've shown you there. They can be more complex. And in the .NET world, we can use them to do some quite interesting things. So let's say we wanted to host an MVC website on Lambda. Well, we have a blueprint for this. So if you go to File, Serverless Application in .NET Core, click OK, and then choose the blueprint ASP.NET Core Web App. What it will do is it will generate a standard or a very similar ASP.NET Core website with, Razor view pages and MVC controllers. It has a couple of entry points. It's got a Lambda entry point and a local entry point. So one, you can debug it locally, and then one is used by the Lambda system as an entry system. They're very similar. One's got an initializer entry, and it's just there's some little bits of work that we've done. We have this thing called a serverless template, which describes the infrastructure required. Now, there's going to be more potentially than one single function involved in this. And also, there's going to be an endpoint, which is going to be required. We're going to use another service called API Gateway to do that. And this little serverless.template just defines all the infrastructure that we're going to be using in our serverless application. So what this means is that when I right-click this application and publish it to AWS Lambda, it uses the API gateway to pass the different requests which come into the MVC routing model. So I'm going to go and create a stack. Here, it's going to deploy it to an S3 bucket, and then it's ultimately going to deploy it to the Lambda service. So all of these things, what they do is they upload a zip file to the service, and then the service then goes and takes that zip file and the code, and then deploys it to the to Lambda. And then at the end, once it's all deployed, I've got a URL, and if I go to that URL, it will load up my ASP.NET Core website. Now, it's actually running this through Lambda functions, but it looks and feels just like a standard MVC application. But what's really interesting about this is that if no one ever visits this website, I don't ever pay a penny. And this would be really good if you're trying to host a website which is like a brochure for a company, or a brochure for something which isn't visited that often. Like I used to write an awful lot of websites for the business entities that ran companies, and you'd have to host things like financial records or like legal documents and stuff which they needed to publicly make available, but they were never really like intended to be visited. So like the Sainsbury's corporate website, not the e-commerce Sainsbury website. Now, not that many people go to the Sainsbury corporate website and find out all about Sainsbury's. I'm sure quite a lot of people do, but it's not as popular as the e-commerce website. And maybe something like this would be useful there, because you are only paying every time someone actually makes a request from that website. You're not paying if no one's making a request from the website. So if you've got a very low traffic website, this would be a very cheap and inexpensive way of running that website, whilst also having the power of C#. And you could obviously make this a static website. There's ways that you could do that, of course, which would also be cheap. You could serve that from S3 if you wanted to. But this gives us the power of MVC and C# and Razor pages. But I only pay if actual people visit it. It's an idea, and it just goes to show you that you can create more complicated applications from something like serverless. It doesn't have to be just a simple API function which has a single response. So lambdas are used, serverless lambdas are used for web applications, for backends, things like data processing. We use them in chatbots. I'm not going to say her name because she's listening in my office, but that Amazon lady or gentleman, depending on the voice that you use, to produce skills for that, you have to use Lambda. So any skill which you ever use on one of those smart speakers is powered using by Lambda. IT automation is also a really common use case for it as well. So I have a Lambda function, for example, that runs on a cron job. So it runs every night, a bit like a service, and it cleans up my account. So it deletes anything that I've tagged in my account as demo. It deletes it. And that's basically a Lambda function which runs on a cron job every night, and it just deletes things in my account which I've tagged. Okay. Now, I've probably overrun a little bit, but I just want to talk to you finally one other service. We don't just produce services at AWS, we also produce tools to help our customers. And some of our customers came to us a couple of years back saying, we really like .NET Core and we want to move to it, because a lot of people want to move to .NET Core. Predominantly, most of our customers tell us that they want to save licensing. So they'll want to move from Windows to Linux because instance costs are basically 30% cheaper because you don't pay for the license to run Windows. So are interested in .NET Core, but they don't really know how they can take their .NET application and convert it to a .NET Core application. And really complicated applications are, got lots of different projects in them. There's lots of APIs. It can be a big job to go and see how much work's involved in that. So we developed this thing called the Porting Assistant for .NET. It's a downloadable application that sits on your desktop, and you can then use it to analyze a solution file and figure out how difficult it is going to be to port it. And it also can even generate some of the skeleton template files and help you along the way of porting your application. And the way it works is this. You download the application, the Porting Assistant from AWS. You don't actually need to be deploying this to AWS to use it. So if you're just wanting to see what it's like to how much work would be involved in porting a .NET full framework application to .NET Core, this tool would help, even if you have no plans to move it to AWS. You choose a porting assistant for .NET. You do actually have to have your AWS profile. If you actually do want to deploy it, then it does use your AWS account. So it's asking what your AWS account is. Click next, and then you point it towards your solution file. Now, this is a version of Nope Commerce, which is like an open source e-commerce engine. This is actually, Nope Commerce has already been converted into .NET Core, but we're using an old version of it, which is still in full framework. And we take that solution, and it goes and analyzes the projects in that solution. So that particular solution has 35 different projects. And inside that project, it's found 52 or 56 projects or packages are incompatible. And API calls, so basically calls to the .NET framework, it's found 1,998 API calls that are incompatible of 3,759. So it's saying this particular application's got a portability score of 47%. It's going to take a bit of work to go and port this application. To give you a little bit more of an idea of how difficult it might be to port it, we create this graph, which basically shows you the interconnections between all of the different projects inside of your solution. So you can see that some of the projects have different connections to other parts and if different projects. What this tool is useful for is figuring out which parts of your application you can fix first. Like what has the most dependencies? So maybe you could say, well, we're going to go for the ones that got the least dependencies because they're going to be the easiest ones to change. Or you might go, well, we're going to go for the ones which have got the most change, like the most dependencies, because we're going to basically get more coverage in our conversion. So it basically starts you thinking about the plan of how you're going to go and port this application. And then you can actually go into the different projects, and you can click on the port project button. And once you've done that, what it will do is it will either produce in place a new version of the application, and it will change all of the project references, it will upgrade all of the NuGet packages to compatible versions, and give you a new project, but on .NET Core 3.1 at the moment. It's on 3.1, and that will be then ported, and then it will keep track of that as well. So you can see now in our solution, we've got one of our projects converted over to .NET Core, and there's still 34 to go. It's a big job to go do porting, but we've got one of them moved over already and ported to .NET 3.1. So if you are in the world of wanting to port a legacy application to .NET Core, then this tool, we built it to help our customers, but you don't actually really need to be our customer to be using it at all. If you're interested in that, I've got a 20-minute video written by one of my colleagues, Steve Roberts, on my blog. It's over on thebeebs.net/port, which gives you a more detailed walkthrough of how he would go and fix that application. Really, that's a whirlwind tour of AWS for .NET developers. I've shown you some of the major services that you'll need to know about. I've explained about Elastic Beanstalk, our container services like ECS and EKS. I've talked a little bit about serverless and AWS Lambda. I've touched on DynamoDB, our NoSQL database. I've shown you EC2 and S3, which are foundational services. And then finally, I've shown you a tool for porting .NET applications from older versions of .NET to newer versions of .NET. And if you are at all interested in AWS and maybe you're thinking, I would like to try building a Lambda function, or maybe I would want to go and install something, but I don't have an account, please do contact me. You can contact me either on Twitter at the Beebs, or email me at mbb@amazon.com, or find me on LinkedIn, or however you want to. Send me a DM or a direct message and just say, hey, I saw your talk and would love a 50, or would like, you don't have to love it. I would like a voucher, and I'll give a $50 AWS voucher, not an Amazon voucher, I'm afraid, sorry, an AWS voucher, which you can then use on your AWS account to start building some cloud infrastructure. So I'm Martin Beeby. If you liked this talk and you thought it was good, then I'm at the Beebs on Twitter. Please go on there and say, hey, the Beebs was great tonight. I loved his talk. It was fantastic. I learned a lot. If you hated this talk, if you thought it was rubbish, if you thought I talked nonsense, if I was too quick, I was too shallow, or whatever it is, then please email me at mbb@amazon.com and let me know how I can improve. There's two GitHub repository. There's a GitHub repository there, which is the GitHub repository for our SDK. If you find any bugs in it, or if you've got any feature requests, then please do make either a pull request or raise an issue on our GitHub account. And also my personal blog is thebeebs.net. Feel free to go there and browse the nonsense that I talk about. Thank you very much for listening to me, and thank you very much for James Langley company for hosting this webinar. And that's it from me for tonight.
Thanks, Martin. Martin, just before you go, there's been a few questions come through on the chat.
Oh, right. Okay. Yeah, sure. Let's go and have a look. Sorry about that. I didn't see them as they were coming through.
Oh, it's okay. I asked people to note down some questions as and when through the talk, and we'll probably address them at the end.
So do you want me to go through them and
yeah, that'd be great. Or if you want me to read them out, it's up to you.
No, I'll do that. I'll do it. So you can't see on the screen at the moment this. So let me think about a way that I could get this on the screen. Okay. No, I don't think I can. Okay, no. I'll just have to read them. I'll just have to read them out to you. Okay.
I think the first one's from David Forrester.
When you get there, why should I migrate from Azure functions to Lambda functions? And do you have any advice about going about it? So yes, I sort of do. So I've done this. So I've taken an Azure function and migrated it to a number of projects. So one FN project, OpenFaz, and I wrote the same Python function across OpenFaz, FN project, AWS Lambda, and Azure functions. There are differences between those projects. I'd say the difference between Azure functions and AWS Lambda is often sometimes Azure encourages you to have an object input and then object output. So you might be writing, it's been a long time since I did this, but you'll have like an input which comes in, but then you'll output an object, and it will automatically write that to something. And there's some capabilities where Azure Functions sort of grabs the object and then it will write that object into a database or something like that. It has some things. If you ever rely on a platform feature like that, that's not going to show up in potentially other serverless platforms. But if you were to write a function which was pretty that it doesn't rely on specific handlers. So you'll see that every example I gave you tonight, it used a handler and like a specific hard Amazon object from our SDK. It doesn't have to. What you could have done there instead is accepted basically receive JSON. And then your function would have to map the different JSON inputs, because you'll get different JSON inputs from something like Azure versus Amazon. So it's completely possible to write cross-platform serverless code, and there's people which do that. Right. I personally, my personal opinion is that I would only be moving from something like Azure Functions if I had a need for it. I'm not going to do it just for a technical reason. You technically can do it. There are technically ways to port it. We don't have any tooling which sort of magically converts them. But if you're sensible about the way you write them, you can make your functions very portable. I used to do a talk called State of the Function, which basically took the same application and I rebuilt it in all the different platforms. And I ended up with one project which worked across all of the different serverless frameworks. Okay, so, but generally speaking, there is a slight difference between the way the AWS Lambda and Azure Functions is architected. I don't know about Azure Functions version 2 because I've not used it, but Azure Functions, the original version, used to be based upon IIS, and so you're effectively running on a Windows machine ultimately. Lambda runs inside of what we call micro virtual machines. They're like very, very small container-based solutions, and they have very, very low latency and very high scalability. We have some of the largest companies in the world running huge, Netflix, Prime Video, Amazon.com all use AWS Lambda at huge scale. So it's difficult to compare the two. They're very similar services, but they're architected in very different ways. I think we do have an advantage in terms of resiliency and scale, but I'm sure that if you spoke to someone from Microsoft, they would say a similar thing. If you have a specific case that you want to show and we can explain why, on a project by project basis, why we think that it's better, then please do come and speak to me and I can speak to you about that. But it's not really a general rule. Sometimes it's going to be easier for you to write on one cloud provider versus another. Maybe it depends upon the experience of your developers as well. But we do have that offering and we've had it for a long time. Is it true that Azure is 5 times cheaper than AWS? No, it's not. So the next question, in fact, I would say it depends on the services and what you use, but there's not a case that Azure is 5 times cheaper than AWS. And if you're finding that it is, for whatever reason, if you've made comparisons, then do come speak to me. We can help you with your bill. Is there an SDK for .NET and Xamarin? Yeah, our .NET SDK will work with Xamarin. There are, I don't know much about Xamarin. I don't use it often, but I have read that our SDK is usable within Xamarin. It's .NET standard based. There are certain things which don't work in Xamarin, but I think generally speaking, you can actually use you can absolutely use the SDK in Xamarin. And actually, AWS is quite popular with. We have quite a few Xamarin customers, and also cross-platform mobile, but also gaming companies with not Xamarin, but what's the game in Unity that use the AWS SDK as well. So yeah, anyway, you can use .NET, you can use the NuGet packages which we produce. We'd be interested to know the options about blockchain service. Does this service provide all the options listed below? Run a node to confirm transactions on blockchain for a particular coin, run a miner on a mine to coin, run a virtual machine to execute contracts, Ethereum virtual machines. Okay, so here's my blockchain knowledge. So you can run a Hyperledger blockchain service, which is that's not Ethereum. But you could run a virtual machine to execute contracts on an Ethereum virtual machine. So let's go from A to B, C. So A, can you run a node to confirm transactions on blockchain for a particular coin? Yeah, absolutely. If you wanted to, we actually have GPU. We have GPU enabled machines. So if you really wanted to do Bitcoin mining on AWS, you absolutely could. I wouldn't recommend it though. There are cheaper ways to run Bitcoin miners. Because generally speaking, so you could mine for coins. Most of the blockchain services, however, the major service that we have is based upon Hyperledger, and Hyperledger isn't a coin, it isn't a currency or a cryptocurrency. It's used for business-to-business transactions, and so it's slightly different to the sorts of things you're asking for there. And we also have a thing called Quantum Ledger, which is a very similar technology to Bit blockchain. Offers a lot of the capabilities. So if you're trying to build this, and really what you're trying to do is create an immutable ledger, then the quantum ledger is probably is what you want to be looking at. So we have a number of different blockchain services. If you're interested in coins and Ethereum, you can absolutely run that on AWS. I don't know much about that world. If you're interested in Hyperledger and building blockchain for enterprises and businesses, I do know quite a lot about that world, and please come speak to me about that. And if you're not sure what blockchain is, but you just want an immutable ledger, which quite often is the case, they just want a database of stuff which can't be changed, then we have the quantum ledger, which may be easier, much easier for you to use. Do you believe applications using EKS Kubernetes will lower costs when they are moved over to Lambda? Does Amazon have a B plan other than Fargate? Do you believe applications using EKS, using Kubernetes, will lower costs when they're moved over to Lambda? Pretty much, yes, I would say, in my personal opinion, if you are able to port an application from EKS over to Lambda, you will probably see savings. And that's true of most applications, because container-based applications require are usually pretty not inefficient, because then containerized application but you're often paying for idle time. So if you've got an EKS cluster, it's using up resources even when it's not being used. So it depends really on the workload. If you've got a workload that's constantly running, then, and it's your maximum, you're using all the compute power in your cluster constantly, then of course it probably would be cheaper to have a cluster and to use it. But if you've got a cluster or a workload that doesn't use all of the resources all of the time, or is up and down, has spikes of traffic and so forth, then if you can migrate it to something like Lambda, then you would almost certainly save costs. It's a good example, which I talked about earlier with Comic Relief. Their application was such that it had been architected previously in a very traditional kind of way, and a lot of the time it wasn't utilizing all of the infrastructure that they had, but they needed all that infrastructure because they had these spikes. Well, Lambda is perfect for that sort of thing, because you're only ever paying for what you use. So it depends on your workload whether EKS or Lambda would be cheaper, and it would be very difficult to make a direct comparison without an actual project. And does Amazon have a B plan other than